Thank you, Catherine. That was a great introduction. So to start, the trauma surgeons that I work with, we discovered that a lot of our trauma patients that we were getting in the ER that ended up coming up to the OR were repeat patients. So these were patients that were being seen multiple times for different reasons that weren't relating to their previous visits, where these patients were involved in different forms of interpersonal violence. So whether that be that they were assaulted or in some sort of like situation where they maybe had been shot or stabbed or something of that nature. And this was really boggling the trauma surgeons' minds. Like, why are our patients coming back for different reasons? And they really wanted to figure out what was going on. And this kind of stems out of Kansas City since they work in downtown KC. So when we were getting together to do this, we wanted to see if there were any correlations. And what we found while we were doing some of the review of the literature is that this has been assessed in a national level. So there is a lot of data on correlations with interpersonal violence in the United States, for example, but there isn't anything that's global. And so we wanted to see if there was anything that kind of like addressed this issue worldwide. So we were really looking at things that correlated across the globe and not just in the United States. And we chose homicide rates because a lot of cases of interpersonal violence, like domestic violence and stuff, those don't go reported all the time. And so homicide rates do. Um, when you have patients or people that are murdered, for example, those have to be reported. And so those numbers are definite. Whereas a lot of interpersonal violence cases, if they're not going to the hospital for their injuries or stuff of that nature, then we're missing those numbers. And so that's why we went ahead and went with homicide rates instead of interpersonal violence rates. So what we did is we looked at a bunch of like government reported websites, and I have a few examples here: the World Bank, World Factbook, WHO, and like UNICEF is another one. And we pulled numbers from all of these databases across as many countries as we could possibly find, which ended up being 227. And we the dependent variable being intentional homicide, and my independent variables are listed on the next slide for you guys. And so what we did was we pulled all these numbers and we were comparing them to the intentional homicide to see if there were any correlations. And to start, I ended up running every single variable that we wanted to address. I did a univariable Pearson correlation. And so that means that I just ran each variable to homicide rate by itself. And so that p-value that we would compare it to would be the 0.05. And then in both of the projects that we did, I ended up running a multivariable Pearson correlation. So I grouped all of the variables in each of those projects together and then ran that with intentional homicide. And so what that does is it looks for any like interrelationships between the independent variables as well, and not just with intentional homicide rate. And so when you do that, you have to correct for any errors, and you have to correct for just like the happenstance that you're going to get something that is significant, because when you do, the more you run a stats test, the more likely you are to get something significant. So it kind of corrects for that as well. And so my two projects had different p variables or p values for those, and they're listed there on the bottom. And so here is all of the, let me see if that's, okay, here's all of the independent variables. And so the column on the left, these were the variables that we looked at first in my very first project. So we have income inequality, Gini index. Gini index is a measure of overall income inequality, and it's a really good measure of like family well-being. We have mental health, infant mortality, life evaluations of happiness. And so that was a survey that went around to populations of a bunch of different countries to assess their level of happiness. Household crowding, which is the amount of people that you have in one household, and then civilian gun ownership. And then the second project that we did is the column on the right. And so these are unemployment and then Gini index coefficient, which is pretty much the same thing, but these numbers came from a different resource this time. I had birth rates, maternal mortality, infant mortality, and then life expectancy at birth. And so all of these were ran with intentional homicide together. And I have the multivariate for the column on the left and then a multivariate for the column on the right. And then each one independently in the univariate as well. So the ones that are bolded are the ones that were statistically significant in the univariate. So with no other factors applied, they had statistically significant relationships with intentional homicide rate. And so what this is showing is that income inequality and the Gini index were in both of my projects were statistically significant. And then as well as maternal mortality ratio, which was really interesting. And then when we did the multivariate, on the left here, those two variables still stayed statistically significant. And then on the right, unemployment rate does not become statistically significant anymore, but life expectancy at birth does. And Gini index and then maternal mortality stayed significant too, which was also pretty interesting. And then here is just my tables that I kind of like reorganized this so it makes sense for everybody that's looking into it with me here. That the p-values in the middle, they for Gini index, it stayed at below 0.001. And so it was the strongest factor that we had found up until this point that correlated with intentional homicide. And then I have the correlation coefficients listed next to it just so we could assess the relationships that we were finding. And so Gini index at this point as well just had the strongest relationship with homicide rates. And so another thing I wanted to point out while we were here was that in the univariable analysis versus the multivariable analysis, the number of my observations were changing, and that becomes significant later. So what this means is that each of the observations is the countries that had a value reported on what my independent variable was. So for example, for the Gini index at the top here, in the top table, I have 175 observations. That means that I had 175 countries that had a value for Gini index that was able to be used in my analysis against intentional homicide. Whereas in the multivariate, when you drop down to the second table, it drops to 46. And so I had a total of 46 countries that had a value for all of these independent variables that were able to be ran in my multivariable analysis. So it dropped my numbers very significantly during the analysis. And the same is true for the second project. So here was my second project, which shows the same exact thing. I've got my p-values and my correlation coefficients and their relationship. And here the Gini index is still the strongest correlation that I had. But my number of observations do drop again down to 166, which was way more than the 46 on the first project, but it still lowers my amount of observations that I was able to run my stats tests on during the multivariable analysis. And then here I have some graphs. So this one is just showing the trend line for intentional homicide rate with the Gini index. And this one again was my strongest correlation. And then here is maternal mortality, and that one had a fairly strong relationship as well, but not as strong as Gini index, but still a positive relationship, which was pretty interesting. So to conclude this, we are just at a point now where we're wondering if there's anything that is a stronger predictor of homicide other than Gini index. And so as of this point, Gini index is our strongest predictor of homicide. We're finding that countries that have really high homicide rates tend to have really high Gini indexes, which just means that they have a very large inequality in their wealth, and the distribution of their wealth is not very equal throughout their populations. How does this affect what we know? So we know that income inequality strongly correlates with homicide rates in the United States, but nothing had ever been done globally. So that it affects what we know because now we're able to apply this to the rest of the world compared to just in the United States, which is a big deal because if we were able to implement any policies, it would need to be something global and not just locally here. So our future research, I have a list of all the new variables that we're going to start compiling data on and pulling to run new stats tests on. And so we are going to take these new variables and we're going to rerun different multivariable analyses. So we're categorizing them into societal or health factors and then economic factors. So I'll have completely new multivariable analyses with new p-values that I'll have to address. But that's where our research is going now. And then I have a fellow classmate here that is looking into all of the countries that don't follow this trend of high homicide, high Gini, or low Gini and low homicide rates. And so what we have a list of countries that have high homicide and low Gini and just the opposite. And so we have a classmate that's looking into that now. I also have a colleague working on this, but in just all of the rural counties of Missouri, and she's finding some pretty interesting factors about that. And then I have another colleague doing the same, but just for Kansas City population, and finding Gini indexes for Kansas City leading back to 1980, I think is the earliest date that we're looking into. And then juvenile gangs is what one of my colleagues has found to correlate with intentional homicide rates more than Gini index. So that's something that is now being discovered as well. And so my limitations for all of this, it's actually been quite a process. A lot of countries don't report on all of the same factors, nor do countries necessarily, like, they're not required to. And so there are several countries that are missing data for the variables that I was looking into, or don't have any data on anything at all because they're not required to report. And then there's also countries that have some, but I don't have numbers for every variable that we were addressing. And then obviously, like with every research project, you have human error. I was manually pulling in these numbers for all 227 countries into my own Excel spreadsheet. And so there's potential for error there as well. And then observations and multivariate analysis. So that was what I was talking about in my tables from earlier, with my countries dropping down to 46 observations, is I think that by limiting the amount of observations I was able to have during the multivariate analysis, could definitely change some of those statistically significant values, especially if they weren't statistically significant before, but then became significant later. I feel like you can't really take that into consideration because your numbers drop. My countries were dropping over 100 values. So that, I think, it kind of sums up the limitations that I've had throughout this entire process. And then I have a link here for my references, and I will take questions.